is that?
Normal.
Normal.
Linear.
Linear, yeah. So usually you have a y is mx plus c for that one. This uphill one would have the m would be positive, isn't it? So m is positive for this one, and m is negative for that one. The gradient is positive. C, and this goes for all of these functions, C is going to be what? Okay, so C stands for constant. It is the y-intercept. So when you look at any function, so even as like x4, x3 plus x, 2x squared plus 7, I know straight away that that function crosses the y-axis at 7. I know that straight away. So that goes for linear all the way through. If there's just a constant number, constant means a number on its own with no x, and x is called a variable. So it varies depending on our input, our domain, but 7 is always 7. It doesn't change, hence the name constant. Okay, so that's linear. That's pretty straightforward. You've done many of those. Yes, very good. The next one is going to be this one, which this one is called linear. This one, of course, is called quadratic. There's a few forms quadratic can take, but let's just talk about the shape first. The general form, I will look at first. Bx plus c, that's a general form. You should be able to recognize a quadratic, sometimes called a trinomial as well, depending on where you are in the world. The A here determines something. It determines the shape.
Oh, so if it's a negative, it's smiley face.
Yeah.
I mean,
Negative, so that's a positive x squared. And that's a negative ax squared. Yeah. So if it's negative, sad face. If it's positive, happy face. And we look at a little bit more quadratics in a second, and the different forms we can write them in and how we can find them. The one after this, I suppose, if we notice the powers here, x squared, x cubed. What's the name of the one for x cubed? Cubic, yeah. So the cubic equation in general looks like this: ax cubed plus, and we had cubic equations already just in algebra with the sequences, a cubic sequence. That's the same thing. This is just what it looks like when we draw it. There's two ways it can go in general: this way or that way. What's the difference? Which one's which? Positive's the one on the left, yeah. How do we know it's positive? Yeah, it's finishing strong. This is finishing weak. So it's going into the negatives. So this finishes in the positives. So this is going to be a positive ax cubed. This is a negative ax cubed if it's finishing into the negatives. Something interesting here, maybe the zeros or the roots or the x-intercepts. How many x-intercepts does a linear equation have? One. How many does a quadratic have? Two. And a cubic? 3. Now, sometimes a cubic or a quadratic can have a repeated root or a 0. What does that look like in a quadratic, for example? So normally we have 2. What I mean by that is 2 places it crosses here. That's 2. Is 3 here and there's only going to be 1 here. This is actually called the fundamental theorem of algebra, but we don't need to know. Just the number of roots of a equation is directly linked to the power here, the main power. But sometimes we get something like x minus 2 squared. And that's just a x minus 2 times x minus 2. If I multiplied this out, I would get x squared minus 4x plus 4. How many zeros or roots, or how many times does this cross the x-axis? How would I find out? Well, I'd let it equal 0, wouldn't I? So it's factorized for me here, and I finish. So this answer, this is the null factor law, which we know so well, of course. X is 2 and x is 2. So it's the same answer. So this is not called one root, it's called a repeated root, which is a minor difference, which won't really come up in this course. It's just interesting. So a repeated root, which means that this particular type of quadratic does what on the x-axis? It repeats. What would that look like? No, it won't repeat like that. It will just, touch off the x-axis. So the x-axis is actually something called, what's that, when a line just touches off the circle? Or tangent, yeah. So the x-axis is actually a tangent, yeah. So it can have only one root if it's repeated. A cubic can do that as well. A cubic can have this kind of weird, it can look like, let's draw it correctly, it can look like that, where it has one and a repeated root. It can look like that. And it can actually have one that kind of lies on the x-axis, which is a triple repeated root, which would be something like x minus 2 cubed, would be a cubic equation as a triple repeated root. That doesn't come up so much, it's just more of an interesting thing. Let's go back to what we need to know.
We have to memorize it.
You need to know the shapes. You need to be able to look at one and go, oh, that's a cubic. And the tangent thing, not so much. It's more, could come up with something like paper 6. It's just, it's a logical progression of what this is, the number of roots. No, you don't need to write. But you can watch the video. Okay, what's next then? What type? We've got two main other types that we look at. I'm not going to go x4. That's a hint.
Geometric.
Exponential, yeah. So exponential is one, yeah. So let's look at exponential style, which has two shapes that we look at. This shape. What would I write the exponential function as?
Something to the power of x.
Yes, very good, yeah. So y is equal to a to the power of x, something like that. Remember, with all functions, so this is exponential. Oh, spell it right.
So it doesn't touch the x-axis.
We can discuss why. Does it touch the x-axis?
No.
That's an asymptote.
Oh, wow. Look at you guys go. Exponential. For all of these, I can rewrite this, of course, fx is equal to a to the power of x. That's the same thing. So that's our function notation. Y is fx. In fact, fx is used much more often in functions than y. Fx describes a whole function. Y describes a whole function as well, but that's more about just a singular output. What's the difference between these two? Like, these are the two main shapes. They're the same, they're both exponential, but something's different. A little bit like a negative here, a is negative.
Is it a root and a square?
It's about the a. It's about the a. Yeah.
A being negative and x being like 3 or something like that. So if the x is not
So this is a greater than 1. This is a greater than 1. It'll have this exponential shape. No negative. We're not looking at negatives here for a. We're looking at fractions for a. So if a is between 0 and 1, it looks like this. What does that mean? So if a is a fraction, or a rational number, if a is a fraction, it'll actually slow down. It'll curve down. And think about that. Why does that work? Like if a is a half, if I have a half to the power of something, half to the power of 3 is 1 over 8. So if a was a half, the input was 3, it'd be 1 over 8. But if a half to the power of even 6 would be a pretty small number. What's a half to the power of 6?
32. No, 30. 1 over small 5.
So
Wait, no.
2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 60. That's 1 over 64. That's quite a small number. Remember, that's your output. This is your input. So that point on the graph would be input 6, so 6 on the x-axis, and 1 over 64 on the y-axis. So if your 1 is here, that's 1/64th, so it's tiny. So see that? Where does it cross the y-axis? Where does it cross the y-axis? So you can see that this one is tending, there's too many points there, but tending towards, where does it cross here? Because there's no constant here. You see there's no constant to say what crosses the y-axis. Where does an exponential cross? Well, what can we do to find where any line or any function crosses an axis? How do we get a y-axis intersect?
We sub into 0.
Sub what into 0? X is always 0 along the y-axis. That's why when we have something like x squared plus 6x minus 7, when x is 0, that's 0, so we know it crosses here. That just goes away with zeros. So with this one, we've y is equal to, let's say, a half to the power of 0, which is 1. So will they always cross at 1? In this form, they will, because they will always be to the power of 0. So this one will cross at 1, this one will cross at 1. Unless it is transformed. So we can look at that in a minute. What do I mean by transformed? If I have y is 2 to the power of x plus 1, that means that moves it up 1. And we look at that not today. Okay, one more to do. I'll rub this up. What's the fifth one?
Mr. Collins,
Yep.
for the fourth one, can A not equal 1?
Yeah, it can equal 1, but with a function that is 1 to the power of anything, it's just going to be, as Alex says, just a straight line. So it's not really worthless to talk about. But yes, good question. Okay, what's the last one we need to look at? It has this shape. It sometimes can have. Yeah, so rational. Sometimes called reciprocal function. So k over x or something like that. So you've also looked at these. What does this look a lot like? Inverse proportion, yeah, as one goes up, the other. Yeah, you can get another shape, yep. So the other shape then would be in this quadrant. It looks something like that. Yeah. So these have those things that you love. Asymptotes. They have a horizontal one and a vertical one. The horizontal one is always called, what does it start with? The horizontal, I fall into the trap. y equals. Horizontal line would go like this. It'll go through the y-axis, but not the x-axis normally. And x equals. So the vertical asymptote was there. So need to remember that because a vertical line is like this. The base case one, so something like this, would have horizontal and vertical asymptotes where?
Near the x and y axis.
Near it, yeah, very near it. On it. On it, yeah. Hmm?
Yeah, if something is on the x-axis, is it an asymptote or no? No,
It has an asymptote of the x-axis. So it's not on it. No, it doesn't touch it. Yeah. So the base case one, the asymptotes of this one, what I'm getting to is just x equal to 0 and y equal to 0. So here and here. It approaches, but does not cross. Why can't x be 0?
Oh, because if you divide something by 0, it's just not.
Yeah, so if we have this as our base parent function, a starting function, if I let x be 0, I have this, and that's dividing by 0, which we're not allowed to do. Why are we not allowed to divide by 0? Because undefined, because it has to work in opposition with multiplication. 6 divided by 0, if we say that's 0, that means that 6 is 0 times 0, which does not work. So it's not working in opposition with the other. Okay, how we find asymptotes? Usually this would be a calculator question, so we can definitely use the calculator for help. Remember to put table. Helps a lot. Use the table. Helps a lot. Or, if we're not sure, for the vertical asymptote, let the denominator equal 0 and solve. So if the denominator is equal to 0, we'll find out what values for x. So let's say we have something like 1 over x plus 2 is our function. If I let this equal to 0, what's the asymptote going to be here? Now, if x was 2, that would be 1 over 4. That's okay. Negative 2. So the vertical asymptote here is x equal to negative 2. The horizontal one for this one is what?
You just sum in the x that you got, no?
Nope.